Okay, Year 12. Here's the last part of the skateboard profile on page 17. Um, it starts here. This is where that negative cubic we've just been talking about finished. And it goes from there, it goes like that. Okay? Now, the first thing I want to maybe draw your attention to is to this little bit over here. Because here in this dotted line here, this dotted curve there, it goes through 0, 1, that all-important point with exponentials, and you would write it like this: y equals a, some base, to the power of x. If, on the other hand, instead of going like this, it does this, then you write it like that. The power becomes a negative power. So you would get y equals a to the power of minus x. If an exponential is doing something like this, then we call that a decay curve or a negative exponential. Now, the reason I'm showing you this one is because the one they've given us that starts there and goes off like that, this one here is a negative exponential. It's one of these that's been shifted along 6 units in the positive x direction. So it's this standard exponential, but it's been shifted along that way by 6 units. Now, if that is the case, you must be writing x minus 6. But don't forget, there is a minus sign in front of whatever the x is. So we have to wrap this x minus 6 in brackets with the minus sign outside like that. Okay? If you remove the brackets, of course, it would look something like that. A to the power of minus x plus 6. All right? So this graph here is going to be of that form there. We don't know A, so we're going to use this point where it starts, 4, 3, to find A. Okay? So if you do that, your bit of algebra might look a little bit tricky, but if you keep a clear head, you should be able to get it. So there is the formula. Okay, instead of y, we're putting in 3, and instead of x there, we're putting in that x coordinate 4 there. And if we do that, we get that 4 minus 6 is minus 2, and it's being multiplied by a minus there. So this minus 2 and this minus here are going to go to positive 2, which gives us the fact that a is the square root of 3. Okay, so the complete equation is y equals the square root of 3, all raised to the power of minus, brackets, x minus 6, like that, close your brackets. Now we need to talk about the domain and the range. Well, the domain is all for which values of x can this graph be drawn? Well, it starts at x equals 4, but it continues all the way along the x-axis. So we will say something like the following, that the domain is all the values of x such that 4 is less than or equal to x, which is less than or equal to infinity. Now, I shouldn't really be putting infinity there because infinity is not a number, it's a concept, an idea. Okay, but I've done that because I'm just being a bit naughty. But nonetheless, just be careful that, bear in mind that infinity is not a number. So we can say that 4 is less than x. You don't really need that bit there. Okay, so How about the range? Well, what are we talking about? The range, well, if you look at that, this curve here only exists uh, for y values between 3 and 0, okay? Because don't forget that this graph here is going down uh, and the x-axis is an asymptote, okay? So it never touches the x-axis. So it can never reach to 0, all right? So the y value can never come to 0. So we have to be careful how we write the range. So there I have written it like this, is all values of y such that 0 is less than y, which is less than infinity. Again, I've been a bit silly here by writing that. But this is the important part there. You can't write 0 is less than or equal to y, because then you would be allowing y to have the value or to take the value 0. And that is not allowed because the x-axis, where y is equal to 0, is an asymptote. And the curve is theoretically never allowed to touch the x-axis, no matter how long you make that x-axis. Okay? All right, now that concludes that mixed graph skateboard problem on the top of page 17. Now I would like you to do the one below, which is got labeled graphs F, G, H, I, and J. Okay. Thank you very much.